Here's the week ahead. Nope, that's wrong. Wrong week. Here we go. 6-1, day 3. We'll wrap it up here hopefully pretty quickly and then get into 6-2. And we'll hopefully, 6-2 is several days, mainly because you just got to see the different antiderivatives and see the pattern. 6-2 doesn't get too spicy until you have definite integrals with what's called U substitution. We'll talk about that today. 6-4 day 1 on Thursday, 6-4 day 2 on Friday. So no summative points this week, all formative. End of the third 9 weeks this Friday. Can you believe it? You are almost 3/4. Actually, probably are 3/4 of the way down with your senior year. If you're a senior. Yes.
Are you almost done grading the test?
Yes, they're going to go in hopefully today.
Oh, no.
You guys are silly. All right. So, how do we feel about this one? What's the easy way to look at this? Start off with, what are the easy slopes to graph? Anytime 0, slope is 0. The slopes are 0 when x is 0 or y is 0, correct? So, boom, 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 y is 0. Boom, boom, x is 0. And then you just kind of have to plug in some values. -1, 1, -1 for x, positive 1 for y. What do you get? 1/2. So how do you graph a slope of 1/2? Well, that's like a 1 is like a 45-degree angle, so 1/2. When x is -1, opposite of -1 is +1. Positive 1 over 2. Yeah. So check your work. They're not necessarily caring about whether that looks like a half. They want to make sure that's a positive slope right there. How about at -1, 2? -1, 2, it's going to be a slope of 2. That was kind of steep for 2. I apologize. Okay. All right. How about 1, 1? -1/2. And do I need to keep going? Or are you guys okay? Get it? Awesome. Moving on. Last night's homework was, Friday's homework. So for some of you, before school started, this morning's homework was 15, 21, 25 through 28, 30, 32. 15, 21. How did 25 through 28 go? It should have been B, C, A, D. B, C, A, D? That was 25 through 28. 30 was kind of nice. It was the slope equals y, so whatever the y value was, that's what your slope is. So those are all going to be the same slope horizontally, yes? If y is 1, the slope is 1. If y is 2, the slope is 2, and so forth. Questions on those? Any of them from the homework you want to see worked out or discussed? I think it was pretty straightforward, yes? Awesome. All right. So I think that wraps up. I mean, we pretty much wrapped up 6-1. I didn't really have much more to discuss, other than I wanted you guys to see a slope field in the AP context. And here, just to show you the scoring rubric, 1 point is earned for 0 slopes. 1 point is earned for non-zero slopes. Okay, awesome. Easy. All right. In to 6-2, which is called anti-differentiation by substitution, aka U substitution. Not me substitution. U substitution. Now, why is it called U substitution? Because the letter U is the variable most often used in the substitution. quick review. This is why I had you memorize it this way. What's the derivative of sine of u with respect to x? Cosine of u times du dx. That's called the chain rule. Why? Because u isn't just u. U is a function of x. So, do you remember last week? What if I see a cosine of 3x times 3? What did that come from? Sine of 3x
Let's see.
plus c. It's gonna be fun. Now, do you agree this came from that because of the reverse chain rule? Yes? So here's what's gonna happen today. Not on problems this easy. You can guess and check at this. But some people may get a little bothered by this. Maybe be like, I don't know what the antiderivative is. Well, the purpose of today's lesson is to say, let u equal the inner part of whatever function is you're dealing with. Square root function? We could write a rule for the square root of u's derivative, couldn't we? I mean, we never did. But couldn't we write a rule for it as a derivative with respect to x? Couldn't we write a rule? Yeah, we have a rule, cosine u times d dx. So if I want to simplify this process, I could call 3x the letter u and then work backwards with a single variable, okay? We'll talk. It's kind of tough to explain at this point. But we're going to be using substitution to make anti-differentiation a little bit easier. All right. Have I used the words indefinite integral yet? You don't need to write this down. Indefinite integral is the same as an antiderivative. There's no bounds, okay? Meaning you're not finding area, you're just finding the plus c function, all right? And we don't need to bother with that. Do we? Antiderivative of 2x minus cosine x? Everybody okay with it? X squared minus sine of x plus c. That is the antiderivative. Very good. Very good. All right. And we know properties. You can add. You can subtract them. I've already covered this. I've already taught you the power rule. I've already taught you L and absolute value u. We don't need to spend time on that. I've already taught you the reverse trig derivative rules, even to the point where we review those on a Canvas quiz. So we are ready to get in to use substitution. Here's our first one. Our example we're going to start off with. Write this down, please. Now, step 1, try guess and check. Don't try use substitution first if you don't have to. The first question you should always ask yourself, do I know the antiderivative of that thing? Spend 30 seconds trying to guess and check the antiderivative of this thing. You got it, Gavin. You got it. Got it, Wendy. You got this, Tessa. Tessa's confident. Lane still wants a calculator.
I do.
Who's confident so far? Take my advice from last week. You know the overarching rule this came from. You do. What has to be in it? Everyone. What has to be in it? E to the x cubed has to be in it. Because what's the derivative of e to the something? E to the something. Oh, it's got to stay with it. So what should you guess first? E to the x cubed. Plus c. I don't know if I've made a big enough deal about that. But 1 point off for each plus c you miss. Ouch. Because there's no bounds. They're not just going to go away. Okay? They're not just going to go away. They're going to stay with it. Now, that's my guess. How can I check it? Well, what's the derivative with respect to x of e to the x cubed plus a constant? The derivative of e to the u is e to the u times 3x squared. That's close. Really close. What's the problem, though? I don't have a 3x squared. I've got a x squared. How do I get rid of that 3? Put a third out front and a third out front. A third out front gets rid of that 3 and makes it a beautiful match. Just a beautiful match. So what's the correct antiderivative? 1/3 e to the x cubed plus a constant. Does that make sense how to adjust? Okay, the worst thing you can do is just be like, help me, I don't know where to start. Don't do it, all right? Get that pencil, put it to the paper, start guessing and checking. You should know the overarching rule it came from. All right, now I'm going to do the same problem. We know the final answer. Good news, we know the final answer. I'm going to teach you the new process today on this problem. All right, the new process is called U substitution, and the purpose of U substitution is to get the integrand, this thing, in a form that you know the antiderivative of. Not a guess and check form, but get it into a form that you know the antiderivative of. You with me? So here we go. The thing you're going to have to do with U substitution is go back to the first semester and remember what I would always say every time we came up to a new problem, a derivative problem. We would always say, what is the overarching derivative rule? Is it e to the u? Is it sine of u? Is it secant of u? Is it the square root of u? Is it 1 over u? Is it, right? What is the type of problem? Is it a power? Is it a quotient? Is it a product? Is it a sine? Is it a cosine? Is it a square root? What rule is it? Because that's where, if you're zoning out, I need you to listen right here. Okay? The biggest problem students have in this section is deciding what to let u equal. And I'm telling you right now, let u equal the same thing it was in the rules you memorized in the first semester. It was e to the u. We're going to let u equal x cubed. What if it was the sine of something? We're going to let u equal that something on the inside. Are you with me? Let u equal the input of the function. Square root of u, let u equal the inside of the square root function. Now, what are we doing here? We're going to convert this integrand from x's into u's. We're going to make it easier, okay? So we have to get, so we're going to have e to the u because we're letting u equal x cubed. But we also need to know what du dx is. Now, you're just going to have to trust me for a couple minutes. I'm going to bring it back to full circle for you, but you just need to trust me for now, okay? Do you remember when we first stepped from Riemann sums into definite integrals, and you asked me, what does that dx mean? And I said it's a differential. It's kind of like a base times a height, right? And I said that variable has to match what? X has to match the variables being used in here. Well, guess what? If I'm converting from x's to u's, don't I need a du there? How do I get du? Well, what is the derivative of this u function with respect to x? What is du dx? 3x squared. If I walked in today and I put this up on the board right here, u equals x cubed, and I said find du dx, or y equals x cubed, find dy dx, or m equals x cubed, find dm dx. If u equals x cubed, isn't du dx 3x squared? And what did I tell you I wanted? I want to know what du equals. Well, how do I get du by itself? Multiply both sides by dx. Du equals 3x squared dx. And from here on out, I'm okay if you jump from this step to this step because you're going to have to do that. You have to substitute du. I'm okay if you jump straight down to there where you just multiply dx to the other side automatically. Fair enough? Now, when you hear the word substitution, substitution, doesn't in math a substitution has to be a perfect fit? Correct? So I want to replace everything else, kind of. Not really the sine or the cosine or the e or the square root, but everything else as an expression with u variables or numbers. So let's check for a good fit. Are you ready? I have 3x squared dx. I look up to my integrand. These are all commutative. I have an x squared dx. What's the problem? I want this 3x squared dx turned into a x squared dx. Do you agree? I don't want the 3 there. How do I get it to just be x squared dx? Multiply both sides by 1/3. So 1/3 du equals x squared dx. Again, this is a substitution process. I have to make it look exactly like what's up above. I have an x squared dx up there. Please pause. Do you have any questions so far? Are you okay? All right, let's go to the actual substitution. I'm going to try to color code this for you to make it as easy as possible. Integral. The e does not change. That is the function I'm working with. But the exponent is now, it's e to the u. And the x squared dx turned into, what is it equal to? 1/3 du. Everything in red got substituted in red. Everything in blue got substituted in u. Now, wipe everything from your mind for just a second. If you walked into class today, if I put this up as bell work, and I asked you to find the antiderivative of 1/3 to the u with respect to u, could you do it? Because if you can't, this whole substitution was either pointless or you haven't learned your antiderivatives well enough yet, and that's okay. All right? Well, what's the antiderivative of e to the u? E to the u plus a constant. And doesn't Doesn't the coefficient go along for the ride in derivatives or antiderivatives, right? Isn't that the correct antiderivative? Last step. I don't want u variables, I want x's. Okay, last step. If there's no bounds, the last step is to plug x's back in. 1/3 e to the, what was u equal to? X cubed plus a constant. Was that what we got when we guessed and checked at it? Yeah. I would argue this process is almost longer using the substitution method. Would you agree? So don't do this unless you have to. Like if you were a person that walked in and you're like, oh, I could guess and check at that, I can get that, then do it. All right. There's going to be some problems that you can't guess and check at it. You're going to have to do this process. So this is our final answer. That's our final answer. 1/3 e to the x cubed plus c. So what the whole u substitution? We let u equal something complicated, something composite, to simplify the problem. It's, oh, I know what that antiderivative is now. Okay, and then we took the antiderivative with respect to u, and then we plugged x's back in. All right, we're just gonna trust me. You're just gonna need to see more of these to get used to it. Go ahead and write this one down. All right. Any ideas on what to let u equal? And it's okay. Most of you don't know right now. But based on my rule, what should we try to let u equal? First of all, is this a composite integrand? You should always ask yourself, is this composite? Sine of 3x, composite. 3x is the inside. E to the x cubed, composite. X cubed is the inside. Dom, did you have your hand up?
I was going to say whatever's under the square root.
Thank you. What's on the inside of the square root is the composite part, isn't it? Okay. So I'm going to try to take that whole chunk and call it u. So let u equal 5 plus 2x cubed. What is du equal to then? Remember, we've already multiplied the dx over. What's du? What's the derivative of u? 6x squared dx. Agree? So now you have to draw your eyes to the rest of the integrand. I kind of know my setup. I'm going to have an integral. I'm going to have a square root. And I actually already know now that my u is going to go under the square root, right? But if it's a perfect substitution, then what's going to be in red needs to be x squared times dx. Do you agree? I have to eat up the rest of my integrand. I have to take up everything else in there. Do I have x squared dx? X squared dx, oh, I've got times 6. Well, that's easy to get rid of. Multiply by 1/6 on both sides. So 1/6 du equals x squared dx. So everything underlined in red is going to get replaced with a, help me out, 1/6 du. Is that a good substitution right now? Is everything taken care of? Yeah. And then you have to stop and ask yourself, do I know that? Do I know this antiderivative? Because the whole purpose of this process is to make it into a form that you know the antiderivative of. Well, yeah. Isn't that u to the 1/2? Am I confusing you guys, or are you okay? Good? Good so far? Kind of? I mean, are you at least following what I'm doing? I'm not asking if you can do it on your own yet. Are you following what I'm doing? Okay, good. All right. You should rewrite this as 1/6 u to the 1/2 du. Isn't this rule a power rule now? Add 1 to the exponent. So I got a 1/6 goes along for the ride. When I add 1 to 1/2, I get u to the 3/2. But I have to multiply by, let me back up. My rule to you has always been add 1 to the exponent and divide by the new exponent. Add 1 to the exponent, divide by the new exponent. 3/2, divide by 3/2, which is the same thing as multiplying by 2/3. Plus a constant. What's a 1/6 of 2/3? 1/9. U to the 3/2 plus a constant. Okay, so that antiderivative was just a little bit messy because of the fractions, but we were able to do it, right? We knew the rule. We used the power rule. Now we have it in a pretty good form. What did we let u equal? 5 plus 2x cubed. That goes in there. So I have 1/9 parentheses 5 plus 2x cubed to the 3/2 plus a constant. That was one you probably could not have guessed and checked out. You couldn't have just sat there and said, just give me a minute. I'll just guess and check this one. Okay? Probably not. Make sense? How can you check these? How can you check it? Take the derivative. What rule would I use here? Power chain rule. Ready? And this is just extra work right now. What's 3/2 times 1/9? 3/18, which is 1/6. Leave the inside alone. Subtract 1 from the exponent. Times the derivative of the inside. And what's 6x squared times 1/6? X squared times the square root of 5 plus 2x cubed. Would you look at that? Isn't that back to the original? So I'm pretty confident we got the right antiderivative up here. Fun. All right, so we're learning new rules. We're kind of doing reverse chain rule today. There's no antiderivative rule for the reverse chain rule other than use substitution, which makes the integrand a little simpler so that we can use substitution to get our answer. All right. I want you guys to try this. This one's very similar to the one we just did. I want you to try it on your own. Sir? What you guys got? All right, help me out. Did we go wrong adjusting? You can adjust for a constant over here. If you get a 2x dx and you look up there and it's not a 2x dx, it's a 6x dx, you need to multiply both sides by 3. Okay? Did you do that? All right. If you didn't, that's usually where we go wrong. A lot of times that's where we go wrong, is adjusting for that constant. Here's another area people go wrong. They don't take the full inside of the square root. Some students will just let u equal x squared. And the problem is you'll have a 1 plus u on the inside, and it'll just be an ugly antiderivative. Okay, it's you're making it more difficult. Help me out. Any questions? All right, we're gonna do one more for today. One with bounds. All right. All right. What's our final answer going to be? I don't mean like number wise, but or variable wise, but it's going to be a function with the x's in it, or a number. It's be a number. Right? Find the area under that function from 0 to 1. It's going to be a number, right? It's going to be an area. It's a definite integral. Is it going to have a plus c in it? No, it's going to be a number. Okay. Any ideas as to what to let u equal? Cool.
Squared minus 4.
Let's try it. Let u equal x squared minus 4. Du is 2x dx. Well, I have an x dx, so I should take, which I do to both sides, multiply by half. So 1/2 du equals x dx. That's going to be a good substitution. Okay. Well, integral, fraction bar. Where does the u go? Bottom. U's down there. Where does the red go? Yeah, I could write 1/2 in the numerator. Isn't that the same as 1/2 out front? Are you guys okay with that? We've done that before. And then the du, 1/2 du is kind of separated, but we know it's multiplication, so we're all good. So what placeholder would make sense to put up in the numerator? Just a 1. Oh, 1 over u. We know that guy. But wait, we need to do something else first. What's missing? What's missing? The bounds. Don't write them in. What kind of bounds were these up here? From x equals 0 to x equals 1. From 0 to 1. Okay? But it's not 0 to 1 on this thing. This has been scaled. There's been a substitution. What bounds are these going to be? Not x bounds. U bounds. How do we get u bounds? Well, go to the u equals function, plug x equals 0 in, plug in x equals 1, and get your u bounds. So here we go. If x is 1, what's u of 1? -3. So the top bound is -3. So when x is 1, u is -3. Are you guys seeing where I'm doing this? Everybody seeing that? If u equals x squared minus 4 and x was 1, then u equals -3. When x is 0, u equals -4. You have to put those on there. No pun intended. Okay? Those cannot be missing. If you're just like, I'm not really feeling that process, I'm just going to leave them blank. The point values on that problem will be left blank as well. Okay? That's kind of harsh, but you get what I'm saying. I wish I had time to talk about this. This is a crazy process that it still blows my mind. You're taking a function, x over x squared minus 4, you're making it look entirely different. The graph of 1 over u looks entirely different. 1/2 times 1 over u. But what's the same? The area from 0 to 1 on this graph is the same as the area from -4 to -3 on this graph. Isn't that crazy? We're making equivalent areas. And we're just going to solve that one because it's easier. It's a crazy process. Here we go. Antiderivative time. 1/2 goes along for the ride. What's the antiderivative of 1 over u? ln, absolute value of u, plus a constant from -4 to -3. Yes? Yes? Now, something I see happen a lot. At this point, students will try to go back to x's. Don't do it. Okay, why? Well, every other problem we've done without bounds, what's the final answer? It's a function of x. What's this answer going to be? Not a function of u, a number. Finish it off. You've already done all this work. Finish it off like this. If you went back to x's, you'd have to go back to x bounds. Just finish it off like this. What do I plug in first? 1/2 ln absolute value -3 plus c minus 1/2 ln 4 plus c. So you get 1/2 ln 3 minus 1/2 ln 4. And yes, there are properties of ln's. You could write it in a simpler form. I'm going to accept that answer for now because the bell's going to ring. All right. Did you follow that? This is one of those times, if you didn't, you might want to go back and watch the video. If you get stuck, watch the video, okay? We're going to do some more of these tomorrow. I need your best attempt at the homework. Speaking of homework, you're going to do a couple from 6-1. Let me double check that, make sure that's good. But the ones from 6-2 are down there. So 6-1. All right. So 35 through 40 are going to be more matching of slope fields. So from 6-1, you're doing 35 through 40. Those are just matching. And then the new problems are on that bottom line down there. 3, 6, 17 through 20, and 24. And 17 through 20, they give you some training wheels. They tell you what to let you equal. And if you really want that calculator, you can hang out for another minute.